Hello, my name's Danielle and I'm so excited to be your new maths tutor. Although this is pre-recorded, remember I am available via my email just here. You can contact me whenever you want, ask any questions. I'm joining you from my conservatory because the light's really great in here, so I thought this is probably the best place to learn. I always like to work on a whiteboard because I think it's really useful to actually see someone writing and for it to be a bit more human like that. I feel like if we're always looking at screens with text written by computers, it's just not the same. So I like to work where you can see hand to paper what I'm up to and follow along. I will zoom in and out, so you will get to look closer at what I'm doing. You won't always have to look at this tiny area here. But yeah, that's a bit about where we are. Make sure you're comfy as well. If you've got a desk or a table, that's great to work on. If you don't, get yourself a tray or a book or something that you can lean your work on. Just make sure you're comfy because you are going to get really into it and be concentrating for a while. I promise you these lessons are actually really fun. You'll be surprised. So yeah, just make sure you're comfy, make sure you've got a drink if you want a drink, get yourself ready for some fun. Before we start the actual lesson, I'm sure you've done it already, but if you can make sure you've got pen, paper and calculator in case we need it. Also, of course, it's up to you how you work, but I highly recommend either working in a book that's specifically for your maths tutoring or working on paper and then hole puncturing them and putting them in a binder or keeping them in some sort of folder or just together in some sort of way. This is a really good idea because you'll build up your own kind of revision guide and that's really useful. Try and work as neatly as you can. Obviously, when you're just working stuff out, you might be really quick. So, maybe have some paper there where you can just do your workings, but try and kind of make your notes in a neat way on a page as well so that you can reflect and go back to it and feel like you know what you're saying. I'll make it quite clear through the lesson, key things that you really want to try and write neatly to have available to remember and to go over and everything else. And then if there's a specific lesson where we're working on something where you would need a ruler or a protractor or something like that, I will tell you in advance so you can make sure that you've got that ready. If we're working on a subject and you finish the lesson and you just don't feel like you had enough on it, you need a bit more support, please make sure you email me. I'm more than happy to help. I do ask if you can help it, don't pause the video and go back within the lesson time. These lessons are set up to be the time that you've got slotted for your tutoring. So try not to pause and go back or anything. Do that in your own time if you want to go over it again or anything else. I will give you adequate time to get on with your practicing with all the explanations and the examples and the way we go through it together. You shouldn't feel like you get behind at all. But if you do, you can go back after the lesson. Just try and do the whole lesson at once at first and follow along the timings that I give you for each thing. Unless you've gone back to a specific topic to do some practice, you will find that this course is done in order. The starter is going to get bigger each week. This is because it's really important that we practice what we've learned. This is what you've probably found it already. If you learn something a year ago and then you're expected to just remember it again half a year later or a year later for an exam or something like that, it's really, really difficult to remember. So one of the really key parts to my teaching and something that I think is vital to do well is that we keep it fresh in our mind what we've been working on. What we do is at the beginning of each lesson, your starter will have a question that's related to the stuff we've done in the past. So as you can imagine, over the course of the course, this starter gets bigger, and nearer the end, half, maybe even more of the lesson can be on these starters. But if you think about an exam, you're literally doing a question on one topic and then you're straight onto a question on the other topic. So the structure of every lesson is going to be a little hello from me. We're going to go straight into times tables. This is something that we'll do every lesson, just a 2-minute, fast as you can. How many times tables can you get in the time? This is really important. I'll explain why on the next clip. Then we'll have your main starter, as I was talking about, will build up over time. Then we'll have the main part of the lesson that we're working on. Okay, so without further ado, let's get on. In the times tables on this video, I'm not using my mic, so I apologise that the sound changes a little bit, but it's only for that times table bit, and then we'll come back to the main lesson and we'll be using the mic again. You won't have a starter after the times tables in this lesson because this is obviously the first lesson. We haven't got anything that we want to go over from last lesson. Okay, let's get to it. Okay, so before every lesson, before every starter, we're going to do times tables just for 2 minutes. You're going to do as many as you can. Either you're going to have a number out of 30, so you're going to have done 10 out of 30 or whatever it is, or you're going to have a time that you've got. Okay, so note this down. So times tables, either note your number out of 30, or if you've got them all, if you're super good at your times tables, because you have to be super fast to get all of them, then you will write down your time, and then every next lesson you're trying to beat that time, okay? So there's no point looking back and cheating, because all that does is to cheat yourself. The reason I feel like times tables are so important to keep practicing is because it's a bit like if you're adding when you're younger, like when you add 2 plus 1 is 3. Like, that feels so easy for you now because you've practiced it so many times. When you first learnt that, that was not easy. So the more practice, the better. And if we do things fast, you're making your brain work fast, it just helps to get it in your head quicker. You do it without thinking. Sometimes you actually know the answers without overthinking it. So don't worry, don't be scared of getting it wrong. Just go for it and see what you get. And honestly, if you get 1 or 2 out of 30 at first, I don't care. No, you don't even have to tell me if you don't want to. No one cares. It doesn't matter. It's not a reflection of how clever you are or anything like this, so please don't worry. It's literally just about practice, and I promise you the people that are better at times tables have just done more practice. There's nothing special about them. There's nothing not special about you if you can't do them. It's just that you haven't practiced enough. So we just need to practice, practice, practice. And the reason that I feel like this is so important is because it's like the base of so many questions. And so if your brain hasn't got to think as hard about that area of the question, you're going to have so much more time and energy to put into the rest of the questions. So if we can just make your times tables as good as possible, then that's the thing we want to do. So I'm going to give you 2 minutes. I'm going to give you 2 minutes to work on this. I will zoom in so you will see them. And then I'm going to show you the answers. And then what I want you to do is take these answers in. So mark your questions so that you can take in what the actual answers are. If you get really into it and you want to pause this video and do that again in your own time, that's fine, but try not to pause it and have another go or anything in the lesson time, because I really want you to work through the lesson while I'm available for you to contact if you need any help as well. Okay, let's go on with it. So get your pen and paper ready, and then I'm going to show you it close up, and I'm going to give you 2 minutes. Ready, steady, go. Okay, your time is up. Let's have a look at these answers. We'll mark these together. So 5 times 6 is 30. Number 2, 4 times 4 is 16. Number 3, 8 times 6 is 48. Number 4, 5 times 5 is 25. Number 5, 8 times 8 is 64. Number 6, 6 times 6 is 36. Number 7, 4 times 7 is 28. I'm forgetting myself there. Number 8, 8 times 7 is 56. Number 9, 9 times 6 is 54. Number 10, 4 times 6 is 24. Number 11, 7 times 6 is 42. Number 12, 6 times 7, if you were clever and you noticed, that was a flip of the other one, 42. Number 13, 3 times 7 is 21. Number 14, 9 times 4 is 36. Number 15, 8 times 6 is 48. Number 16, 3 times 8 is 24. Number 17, 7 times 4 is 28. I always forget that one. Number 18, 6 times 3 is 18. Number 19, 7 times 7 is 49. Number 20, 6 times 7 is 42. Number 21, 9 times 4 is 36. Number 22, 9 times 9 is 81. And yes, I'm looking at my hands. I do use the hand rule for the 9 times table. If you don't know it already, I'll quickly show you. So you've got 10 fingers, 1 finger down. Whatever finger down is the times table that you're looking for. So if you're doing 9 times 4, put the 4th finger down. Anything on this side is the tens, this side is the units. So like 36, 9 times 6, put the 6th finger down, 54. So that's quite a good method to use if you don't already. But the only issue with it is, like me, I now rely on it, whereas the other ones I just know. So yeah. 3 times 9 is 27. 8 times 7 is 56. Nearly forgot that one. 4 times 5 is 20. 8 times 9 is 72. 7 times 6 is 42. 4 times 6 is 24. 6 times 3 is 18. And 8 times 2 is 16. There you go. Let's show you the answers closer. The simple reason why I want you to take down your score or your time is because you'll do the same times table challenge next lesson, and I want you to be able to see yourself improve over time, because it's a really nice feeling when you can see that your work is actually making a difference. Okay, so let's get on to our lesson. Now, lesson today, we are focusing on indices. If you don't know what indices are, these are powers. So these are like the little numbers. You know when you see like 4 squared, that 2 is an indice. Some people do know them as powers, but you want to think of them as indices. In GCSE, there are certain questions that come up that are on the rules of indices. So that's what we're going to look at today. What's really nice about rules of indices is that as long as you know them, the work is actually really simple, but the question looks like it's going to be really complicated. And I always like this sort of thing in maths because it makes you feel really clever when actually it's really quite simple. It's just knowing. So there's 5 rules you need to know. You know, I said that I'd make it really clear on the parts that you want to make really neat. This is one of them. So I want you to write down everything I write down. Don't worry about the fact that it looks really complicated, or if you don't understand what I'm doing. I haven't taught you it yet, so I'm not expecting you to know. You might have seen it before. If so, then it's just a really good reminder and a really good bit of practice to get better at it. We're going to write down the table and then we'll work on each rule at a time. So you're copying the table down. You don't need to worry about knowing any of it yet. So on the left side of the table, you're going to write rule. And then on the right side of the table, you're going to write example. Okay, so this is our table. This is what I want you to write down for me as neatly as possible. Write it down without worrying about what any of it says or trying to understand any of it, because we're going to go through it bit by bit. Okay, so hopefully you paused and managed to get all that written down, because I'm going to now wipe it off the board and we're going to get on with the first rule. Okay, so this first rule we're looking at is a to the power of x plus, wow, I'm doing it wrong already. A to the power of x times a to the power of y equals a to the power of x plus y. Okay, so all this means is that a is any number, okay? So the number has to be the same here and here for this rule to work. A number to the power of another number, so that could be 2 to the power of 3, 9 to the power of 1, whatever you want, times by the same number to the power of another number, or it could be the same, equals the 2. Okay, so all this means is really simple. As long as these 2 numbers are the same, we can just add the indices. It's like a shortcut, okay? I'll show you why it works. So let's say we had 4 to the power of 3 times 4 to the power of 4. And what it's saying is that we can just do 3 plus 4. So we get 4 to the power of 7. Now let's just quickly look at why this works and then it will make loads of sense. Okay, so 4 to the power of 3 is actually 4 times 4 times 4, isn't it? We know that a number to the power of another number is just that number times by itself that many times. 4 times 4 times 4. Then we've got a times. And then we've got 4 to the power of 4, which we know is 4 times 4 times 4 times 4. Okay, now we've actually got 4 times 4 times 4 times 4 times 4 times 4 times 4. So sorry about my squeaky chair. So we have got 4 to the power of 7. 1, 2, 3, 4, 5, 6, 7. 7 fours times together is 4 to the power of 7. That shows you how what we're doing is the same thing. It's just a simplified way of doing it. Okay, so let's do 6 to the power of 5 times 6 to the power of 3. So we literally write the 6. We don't worry at all about the big number. It's just staying the same. And then we add the 5 and the 3. And we get an 8. Again, 3 to the power of 2 times 3 to the power of 10. Keep the 3. Don't worry about the big number. It just stays the same. Add the indices. 10 plus 2, 12. One more for luck. Let's do 2 to the power of 7 times 2 to the power of 4. Keep the 2. Add the indices. 7 plus 4 gives us 11. Okay, let's get you to try some. Okay, here are 8 questions to try. Try the first one, then we'll go through the first one just to make sure you're definitely on track, and then I'll let you go through all the rest. So, first one is 3 to the power of 2 times 3 to the power of 4. I'll give you 30 seconds, have a go, and then I'm going to tell you the answer. Okay, if you knew how to do it, that should be done. So let's just double check that you're on track. You would have kept the 3 as it is, so the big number stays the same, and then we add the little numbers. So 2 plus 4 is 6, so you should have 3 to the power of 6. Go ahead and try the others. Okay, so go give the rest of those a go. I'm going to give you a couple of minutes and then we'll mark them. I have thrown in a few wildcard negative ones at the end. Follow the same rule and you should get the right answers. But if you do get stuck, don't worry, I will be explaining when we go through the answers. Okay, let's have a look at some of these answers. 5 to the power of 5 times 5 to the power of 6. You should have got 5 to the power of 11. 5 plus 6 gives us 11. 9 squared times 9 to the power of 7 should have been big 9, and then 2 plus 7 would have given us 9. 8 to the power of 8 times 8 to the power of 8. So we've got the big 8. And then we've got 8 plus 8, which would have given us 16. 2 to the power of 3 times 2 to the power of 9. Big 2, and then 9, 10, 11, 12, 2 to the power of 12. Now, we're on to the slightly tougher ones. I've just realised I've done my numbers in a weird way. Sorry about that. 4 to the power of negative 2 times 4 to the power of 3. So we do negative 2 plus 3. Now, negative 2, negative 1, 0, 1. So negative 2 plus 3 is 4 to the power of 1. If anything is to the power of 1, we can just write 4. Like, we can just write the number. 6 to the power of negative 1 plus 4. So we've got the big 6, and then we've got negative 1 plus 4, which gives us to the power of 3. Negative 1, 0, 1, 2, 3. If you struggle with your negative numbers, I always tell people, think of it like it's money in the bank, okay? If you have a bank account with an overdraft, you can go into overdraft, which goes into the negative. So you can overspend. So we could be on negative 1 in the bank, and then we could add £4. We'd have £3 in the bank, because that negative 1 that we'd already overspent by 1 would have been taken first, and we'd only be on 3 even though we put £4 in. Same here. We could be on negative £10 in the bank, and now we're going to add £20. We're only going to have £10 in the bank, aren't we? That first 10 is being used up with that negative that we already spent. That's how you want to look at it if you struggle with your negative. That's what I find really useful. Okay, so there's all your answers. Mark yours, see if you got them all right or if you got any wrong, and let's go on to the next rule. Okay, so the next rule is basically the same as the last one. It's just divide, so it's the opposite. So we've got divide, which means we minus the indices instead of adding like we were on the multiplication a minute ago. Let's do a few examples together. Let's have 8 to the power of 6 divided by 8 to the power of 4. We do 8 to the power of 6 minus 4, 8 to the power of 2. So we're literally keeping the big number the same as we were before, and we are subtracting those indices. Let's try another one. 6 to the power of 5 divided by 6 to the power of 2. 5 minus 2, 6 to the power of 3. Okay, let's try one with a negative. So let's say we had 6 to the power of 3 divided by 6 to the power of 6. Now, you have to be really careful. Like any time with subtraction, you don't want to flip them round and do 6 minus 3. You need to keep them in the order that they're in. So if we've got 6 to the power of 3 minus 6, we need to have it as 3 minus 6. Now, £3 in the bank, we're going to spend £6. We've got an overdraft. If we have £3 in the bank and we spend £6, we've got negative £3 in the bank, haven't we? Because the £3 we had got taken up, and then we needed to borrow another £3, so we're on negative 3. That feels really quick, but because it's so similar to the one before, it shouldn't be too complicated. So I'm going to go straight onto an exercise. We'll do the same thing. We'll try the first question, I'll mark it, and then we can go on to the rest. Okay, let's go. Apologies for the change of pen partway through, but that pen was running out. What I've tried to do in this one is I've also tried to add some negatives that are a little bit trickier, just to really get our brains working. 2 to the power of 7 divided by 2 to the power of 4. I'll give you 20 seconds. Go. Okay, so we've got 2, and then we've got 7 minus 4, which is 3. If you struggle with your subtracting, remember you can think about the difference between them. So sometimes I like to write the numbers underneath each other and think about how I get from one to the other. So for example, if I'm doing 7 minus 4, I'm looking for that difference, the numbers in between those two. If my brain is one that works better going up, I might write 4 and think, how many do I add to get to 7? And I add 3 to get to 7. 4, 5, 6, 7. So I know 7 minus 4 is 3. So if you prefer to just find that difference between the numbers going up, that is totally fine. You do it however works best for you. That is a little way that I like to share sometimes if you have a brain that really struggles with the going down, because I do. And sometimes it's nice to be able to visualize it a different way if your brain works better that way. You just want to work to your brain. So any way that makes things easier is a good way to go. Okay, so now you're going to go ahead and have a go at the rest of these on your own. And I will give you a couple of minutes to have a good go at that, and then we'll do it together. Okay, let's go through it. Number 2, we've got 4 to the power of 9 divided by 4 to the power of 6. Okay, so we've got a big 4. And then we've got 9 minus 6. And the way I just explained how I would go, I start at the 6, I go 7, 8, 9, that's 3. So 4 to the power of 3 is what you should have there. For number 3, you've got 9 to the power of 2 divided by 9 to the power of 3. Big 9. Please don't tell me you've got a 1. This is 2 minus 3, not 3 minus 2. Okay, so just kick yourself if you don't actually kick yourself. If you did it the wrong way, you know what you've done wrong now. You had £2 in the bank and you spent £3. You are now on -1. Number 4, 3 to the power of -5 divided by 3 to the power of 10. Big 3. Now we've got -5 minus 10, not 5 minus 10, so you shouldn't have -5 as your answer. You started on -5. Think of your bank account, visualize that -5. Now you're spending another tenner that's not yours. So now you're on -15. 8 squared divided by 8 to the power of 4. 8 to the power of -2, because you had £2. Remember, always working left to right. It's really important. Do not flip your numbers. We're starting on 2, 2's in the bank, and we're spending another 4. We are on -2. 5 to the power of 6 divided by 5 to the power of 4. 5 to the power of 2, because we're on 4. 5, 6. The difference between 6 and 4 is 2, so 6 minus 4 is 2. 5 to the power of 2. 12 to the power of 9 divided by 12 to the power of 3. Again, we can do it the way that I like to do it. So we're on 3, 4, 5, 6, 7, 8, 9. So it's 6. So we've got 12 to the power of 6. Or the other way around, you're just doing 9 minus 3. You might literally just do 9 minus 3 in your head. I just like to talk about that, finding the difference way, because it's really useful to me and my brain. Okay, and then we've got 15 to the power of 4 divided by 15. There's no indice on that 15. What does that mean the number is? It's not 0, it's not 2, it must be 1. The only number that we don't write down, if it's there, is a 1. 15 to the power of 4 divided by 15 to the power of 1. That's 4 minus 1. That is not 4 minus 0, okay? If we had a 0 there, we're going to look at a rule that's got a 0 later. So 15 to the power of 4 divided by 15 to the power of 1 is 15, and then 4 minus 1 gives us 3. You should have got 15 to the power of 3. Super well done if you got that one. Don't worry if there's any you didn't get right, especially if it was down to just struggling with your negatives over actually knowing the rule. The thing I care the most about on this lesson is that you understand this rule. So putting some negative ones in there, making it a bit trickier. If any numbers went wrong, don't worry, as long as you know that you've got to minus or subtract those indices whenever you have a divide come up. Cool, let's go on to the next rule. Okay, this rule is a to the power of x to the power of y equals a to the power of x times y. So these can be any numbers. All you've got to worry about is that you are timesing the indices together, and the big number stays the same. Okay, so let's try this with a real life example. 2 to the power of 4 to the power of 2. So all we do is we write the big 2, and then we have 4 times 2, which is 8. So our answer is 2 to the power of 8. Okay, let's try another example. So 3 to the power of 3 to the power of 10. So we keep the big 3, we do 3 times 10, which is not 10, which is 30. So we have 3 to the power of 30. It's as simple as that. Okay, now let's try an exercise. So you know the drill now. Have a go at that first one without me, and we'll go through that in a sec. Okay, so we've got the big 2, and then we've got the 5 times by 2 to give us 10. So you should have 2 to the power of 10. Now I'll leave you to have a go at the rest of the exercise, and we'll come back together in a few minutes to go through them all. Okay, now let's have a look and a go through these. So the first one we've got is 3 to the power of 2 to the power of 6. So the big 3 stays the same. 2 times 6 is 12, so you should have 3 to the power of 12. 4, then you've got 2 times 5, which gives you 10. Next one, number 4, you've got 5 to the power of 6 times 3. So you've got the big 5, 6 times 3 gives you 18. On to number 5, you've got 6 and then 2 times 3. Big 6 stays the same. Be careful, because I always find with the 2 and the 3 ones, people always accidentally add and give me 5. And it's of course 2 times 3, which gives us 6. So just watch out for that. If that was you, you are not alone. A lot of people seem to do this for some reason. Always with the 2s and the 3s. Okay, the next one, number 6, we've got a big 8, and then we've got 4 times 2. So you carry the big 8. 4 times 2 is 8, so you've got 8 to the power of 8. Number 7, you've got a big 9 to the power of 2 times 7, so big 9, and then 2 times 7, giving you 14. And then number 8, you've got an 8, and then you've got 3 times 2 again, which gives us 6. So there we go. Check your answers. I hope you did okay there. Well done if you got them all right. And we can go straight on to the next rule. Okay, this one is a next rule that I love. It is a to the power of 0 equals 1. This means any number to the power of 0 is just 1. 10 to the power of 0 is just 1. 9 to the power of 0 is 1. 2 to the power of 0 is 1. 3 to the power of 0 is 1. 5 to the power of 0 is 1. Okay, so as this one is pretty straightforward, we're going to go straight into this exercise. I've just given you 3 questions, really simple, just a few minutes. If you can just get that done, we'll go through it very quickly. Okay, this is going to be hard to mark. 2 to the power of 0 is 1. 6 to the power of 0 is 1. 3, 7 to the power of 0 is 1. Well done if you got them all right. Okay, we're going to go straight on to the last rule, and I'm going to talk through this closer up to the board, and let's get this one done. Then you have finished indices. How exciting! Let's make it happen. As you can see, unfortunately, my sound decided not to work for this last rule. So what I'm going to do is I'm just going to zoom in and teach you this with the voiceover, like I have with a few of the others. Okay, so this rule is a to the power of negative x equals 1 over a to the power of x. Now this looks a lot more complicated than it is once you know it, just like everything in maths. Literally, when we put numbers in, you'll see how easy it is. Let's have a little look at an example. Okay, let's try 3 to the power of negative 2. Okay, so let's just literally follow the rule exactly as it is. So we put 1 over, and then the a is the number that becomes underneath, so the 3. So it's 1 over 3. And then if we look at where the negative x is and then where the x becomes, the x is the 2. The negative just tells us it's 1 over, so it's not going to be to the negative 2, it's going to be to positive 2. So the negative has kind of done its work separately, and then the 2 goes there. That's how I look at it. So then we've got 1 over 3 squared, and then we can do the 3 squared, so we get 1 over 9. Okay, let's look at another one. So 5 to the power of negative 3. So maybe pause the video and have a think. Where do you think that 5 is going to go? Where do you think the 3 is going to go? So the 5 goes underneath, and then the 3 is going there. Remember, you forget the negative because the negative has done the work of putting it as 1 over, and then the 3 is doing its own job of going above that 5. There I'm just showing you that the negative is the 1 over, and the 3 goes above the 5. Now we can do 5 to the power of 3, which means 5 times 5 times 5. So 5 times 5 is 25. And then timesing that by 5 again, and you'll get 125. Okay, so you've seen a couple of examples, so I really should be expecting that you'd be able to do this one on your own now. So let's try 4 to the power of negative 2. What do you think that's going to look like? So you've got the 1 over, and then the 4, and then the 2 becomes 4 squared. 1 over 4 squared. 4 squared, remember, is 4 times 4, which is 16. A little trick if you struggle with your 4 times tables at all is I love to do things times 2 and then times 2 again. So for example with 4 you can do 4 times 2 is 8 times 2 is 16. Okay, now it's time to have a good old proper practice. So I've got you 8 questions here. Do them in your own time. I'm going to leave this up in silence so you can focus and give it a real go. Shouldn't take you too long, hopefully, apart from some of the timesing might take you a little bit longer. Try not to use a calculator if you can, because these are all ones that you could be given without calculator. And yeah, give it a go and then we'll go through it. I will just do the first question just to kind of set you off. So that's got 2 to the power of negative 2. So following the usual rule, you should end up getting 1 over 2 squared, which is 2 times 2, which is 1 over 4. Well done if you got that, and crack on with the others. Okay, I'm going to go through it with you now. If you are not finished, just pause the video, that's absolutely fine if you need to just quickly finish off. But otherwise, let's take a look together. So, the number 2 is 3 to the power of negative 4. So you've got 1 over 3 to the power of 4. Now, 3 to the power of 4 is 3 times 3 times 3 times 3. So 3 times 3 is 9. 9 times 3 is 27. And then for the 27 times 3, I'm just going to add them all up, written down, and I get 81. So 1 over 81 for that one. I'm going to carry on the video fast and see if I can keep up. So the 5 to the power of negative 2, you should be 1 over 25. 6 to the power of negative 2, 1 over 36. 2 to the power of negative 3, 1 over 8. 3 to the power of negative 2, 1 over 9. And 4 to the power of negative 3, 1 over 64. Again, I added up a bit there, you can see my working out. You have finished the whole of indices as a topic. All of the rules, you know them. How exciting is that? And then it's literally just a case of us making sure that you're reminded how to do each one in the starters each week.